Alright guys, so this is our homework help video for your study guide for the exam. Let's go ahead and get started. So the first thing you're going to be asked to know how to do is to find nth roots. We have cube roots, fourth roots, fifth roots, whatever number's out here. That's how many you need to take. That's how many you need in common in order to take it out of the root. So I'm going to break down the 24. That's going to be 8 times 3 and 4 times 2 and 2 times 2. So 24 breaks down into 3 2s and a 3, as well as we have x to the 5th, which means I've got 5 x's there. And this is a third root, which means I'm looking for groups of 3 identical numbers being multiplied together. If you have those, you can take one of those out of the root and then cross off the root. There's another one. So I can also take out an x. So those are the two things I could take out. But these things have to stay inside. So inside of the root, we have a 3 and then 2 x's. After that, basically just multiply what's together. So the 2 and the x, you multiply those together to get 2x, right? And then 3 times x is 3x squared. So I'm going to be doing the odd problems. You guys can do the even problems if you want to earn a few extra points. Let's see how many different types of problems we've got here. All right, so number 3. This one we're looking for a fourth root. So I'm going to break down 405. 5 is going to go in there 81 times. 81 is 9 and 9. And both of those 9s make 3's. So we have 5 with 4 3's. And then we have 5 n's. And we're looking for groups of 4 identical numbers. So I've got 4 identical numbers here, so I could take out a 3. And I've got 4 identical values here, so I can take out an n. And what's left inside of this radical is a 5 and an n. Let's go and take a look at number 5. Something I want to remind you guys about before I go on to number 5 is that when you guys get to a cube root or a fifth root, anytime this is an odd root and there's a negative, the first step you do is take out the negative. But from there, it's all the same. Okay? So I'll let you guys handle that one on your own if you like. Okay, so here's another type of problem we looked at. For this one, what we talked about was you want to think of that 6 as a 6 over 1. And then we use the rule for exponents where you multiply those together. That would be a to the 18 over 2 then. Top times top, bottom times bottom, and then you reduce. So that's a to the 9th power. Okay. Next one puts a different little bit of a spin on it. The first thing we do when you have both a number and a variable in there is, first of all, you're going to split those two things up. We're going to put the 81 and the k squared separately. And then we're going to apply that exponent to both of them separately. Okay, so for the k squared, it's going to be 2 over 1 times 3 halves. So that's going to be 6 over 2, which is 3. Now as for this one, though, when you get to the number, you actually need to rewrite it as a radical and then work it out. Now in this one, you could break it down if you wanted to, but this is just asking for a regular old square root of 81, which I'm sure many of you guys know is 9. Now, 9 to the 3rd power, 9 times 9 would be 729, I believe. That would be your final answer. So the big aha here is that when you have a number and a variable, you apply the power to each one separately. Okay. Let's go ahead and move on to another here. Negative exponents. So in this case, we have k to the 9 over 1 being raised to the negative 4 over 3. Multiplying these, we get negative 36 over 3, which is negative 12. But we're going to go one step further. The way that this works is when you have a negative exponent, you're going to rewrite that same expression in the bottom, but with a positive exponent, and put a 1 on top. This just makes it a reciprocal. That's all a negative exponent to do. Okay. Let's go ahead and check out another. This guy here. So since there's a number and a variable, we're going to treat them separately. We're going to do 49 to the negative half power, and we're going to do x to the 6th to the negative half power. Okay. So first of all, let's go ahead and do the letter 1. 6 over 1 times 1 over 2 is going to be, for the negative, is negative 6 over 2, which is negative 3, which is 1 over x to the 3rd power. Okay. This guy here, we need to first of all rewrite it as a square root being raised to the negative 1 power. The square root of 49 is 7, and 7 to the negative 1 is 7 to the 1st power on the bottom of a fraction with 1 on the top. And then multiplying these together at the end to get our final answer together is this. Okay. So in this one, and the last one, the aha is that negative numbers cause it to become a reciprocal. So like from here to here, for instance. All right. We're also going to look at solving radical equations. So the first thing you do is you get rid of numbers that are outside of the radical. Then you square both sides. The squares cancel out square roots. And then you divide both. In this case, we would divide both sides by 2 to get 32. And you always want to make sure that your answer, if you plugged it into the square root, will not make the radicand anything negative. In this case, it doesn't, so we're good. And our answer is, in fact, 32. Okay. This is an example where you have a square root on both sides. In that case, you just square both sides right away, and you end up with this. And then from there you use algebra, so you're going to move the smaller variable to the other side so you can combine those together. That makes 2n plus 3 equals 9. And then from there just use some basic algebra to solve it. N equals 3. And once again, you want to plug that in up here to make sure it doesn't make the radicands negative. So if I plug in 3 for n on both sides here, here I get 6, here I get 6. Neither one of those are negative, so that's a good situation, and that means that is in fact a good answer. All right, moving along. Let's check one of these out here. So we're going to start by squaring both sides again. But in this particular case, we have a different situation. We have an n squared and a regular n. When that happens, you have a quadratic situation on your hands. And the way that you're going to solve for n is going to be very different. What you're going to do to solve for n in this case is you're going to add or subtract everything from one side onto the other side. So I'm going to add n and subtract 12 on both sides so that on the left we have 0, but now on the right we have n squared plus n minus 12. Now at this point you can use the quadratic formula if you are comfortable with that. It will work. But that's not how I'm going to do it. I'm going to go ahead and go with a factoring approach. So that's what I'm going to do. But quadratic formula does work. So I'm going to factor this. Put n squared here, negative 12 here. And then what makes 12 would be 3 and 4. Now I know I need to get a positive 1n in the middle, so that means the 4 needs to be positive, and the 3 needs to be negative. And so I end up with n plus 4 times n minus 3. And then we do the zero product property to solve for n. So n plus 4 equals 0, n minus 3 equals 0. So in this case, I get n equals negative 4. And in this case, I get n equals 3. But once again, we got to check our answers. We want to make sure it doesn't make anything negative. I think we're good. I can tell as I look up here that shouldn't be a problem. So we take our expression, 12 minus n. So if you put negative 4 in, double negatives becomes positive, and you end up with 16. So that's a good situation. And then we also have to check the other value we got for n there, 12 minus 3, which is 9. And that's also positive, so we're good. Okay? Both of those are good answers. All right, let's do one more of these, I think. Once again, I'm going to put this in parentheses, and what we're going to do is we're going to square both sides to get rid of that square root, right? Now, in this case, we're squaring a plus 1. Now, if you're squaring a plus 1, that means this, which means you could do a box method if you wanted to get the answer. But Mr. Bailey doesn't like the box method because it takes too long. Instead, Mr. Bailey likes the shortcut that he shared with you. But if you want to use the box, go for it. So the shortcut works like this. You square the first term. You square the last term, 1 to the second power of 1. And then you double this number and put this letter next to it. That's simple. That's what Mr. Bailey prefers. But you can do whatever you like. Okay? But once again, you'll notice that we have a quadratic situation again. I've got an a squared and a's. So when that happens, the way that we solve for a is we move everything to one side. So I'm going to move these two numbers off the right side and onto the left side. So bring down the a squared. 2 take away 3 is negative 1a. And 1 take away 43 is negative 42. And then I'm going to go once again with a factoring approach to solve this. But once again, you could use the quadratic formula. Box method, because it's got 3 terms. A squared here, negative 42 here. A times a makes a squared. 42 comes about by 7 and 6. I need a negative 1a in the middle, so that would mean, in this case, the 7 would have to be the one that's negative. That way, when I add these together, I get a negative 1a. So this thing has been factored into a minus 7 and a plus 6. We do zero product property after that. So I get 7, and I get negative 6. Check our answers to make sure they don't make the radicand something it shouldn't be. The only radical we have is this one. So we have 3 times something plus 43. We want to make sure that 7 works, so let's do that. Well, if I plug in 7, that's going to be 21 plus 43. That's positive, so that's going to be good. Let's try the negative 6 one. So in this case, 3 times negative 6 makes negative 18. But when you add it to 43, you're going to come out with a positive number, so we're still good. What would 43 take away 18 be? 5 and 2 maybe? So it works. So both answers work, but don't be deceived. Every problem I've given here in the study guide works, but every once in a while there's that one that creeps up where even though you did everything right, the answer turns out to be no solution. All right, when we get to numbers 13 through whatever, I probably won't do all of these ones, but like I said, you're welcome to do all of them if you want to get some extra points. But this is graphing. So we talked about 2 kinds of graphs. We talked about the square root graph, which looks like this, and we talked about the cube root graph, which looks like that plus a little bit more on the other side. Either way, they both have a starting point, which we'll put right about there. And this number is here and here comprise the starting point. So we take the opposite of that number, and that number is 3. That's my starting point. Over 2 up 3. Starting point is there. When you have a positive on the outside and a positive on the inside, it's up and right. And so that graph would look like that. Let's take a look at this one. In this case, we're missing a number over here, so that would be 0. Since we're doing square roots, it's the square root shape. My starting point would be -3, 0. Now I'm going to be going to the right because my x is positive, but the square root itself is negative, so I'm going down. So I'm going to be going right and down. So it looks something like that. Okay, now we're dealing with a cube root, so we're looking at the cube root shape now. We're missing a number over here, so I'll put 0. So my starting point will be -4 and 0. So we're going to be going to the right, and we're going to be going down again. But since this is a cube root, we're going to throw on the other half there. That's what cube roots look like. That's the end of that one. Pretty chill. All right, on this one, we have the number that's outside the square root, but what we don't have is the number inside of the square root. So I'm going to rewrite it like this, just so it looks a little bit more familiar. So in this case, my starting point would be 0, -5. And it's positive here and here, so that's up and to the right. And since it's a cube root function, we have the other side as well. And that's that, guys. So, see you tomorrow for your test on square roots.